Okay, so we have this situation here. And again, I took this situation from one that's going to be like your upcoming test. So you're sort of familiar with how the thing goes. So just read and analyze and just tell me what you think about this. What do you think? Anybody? Anything grab your attention right off the bat? Anything looks like you could translate English into algebra here?
3 miles would be the y, like be 3 equals.
Okay, let's go ahead and construct that. Now I'm going to kind of let you lead me, okay? Now, so I'm just so Jaden is the first one I heard
Never
say.
mind, I read that wrong. I meant like the 2 hours. He runs 2 hours a day, right? He runs 3 miles every 15 minutes for 2 hours. So it'd be.
Okay, so we could go. So I just sketched a little graph in there, a little XY coordinate plane.
3 would be the y. No, I don't know.
So you would start at 0, right? Because if he doesn't ride that, doesn't ride for
okay.
For 0 minutes, then there's no miles.
Yeah. So Bryce makes a suggestion. Okay. Bryce suggests, hey, let's just start right here at the origin, right?
Right.
So he's made an executive decision for us. Yeah, we're going to just continue with that, if you don't mind, Bryce, and then just kind of see where that leads us. And is that a good place to start? So in the language, let's just go ahead and follow on. So what Bryce said, what is our y-intercept of this function going to be?
Yeah.
So we'll say y-intercept is equal to 0. Okay, good. Okay, so Bryce gave us a good piece of what we're looking at here, all right? What else?
The miles is the y-axis.
So Ben is suggesting that maybe we put miles over here someplace, right?
Yeah.
Okay.
And that means times the x-axis.
And so time, all right, time. And so we're going to have 3, okay, so, all right, good.
So would it be in minutes or hours?
So Ben is asking the very critical question here. Okay, we got minutes and hours.
I would say it'd be in minutes because that he runs 2 hours a day. And he runs 2 hours no matter what.
So you want to go in minutes?
Yeah.
Yeah, because what if he runs, or if he does 3 miles every 15 minutes, what if he does 20 minutes, and that's 4 miles?
Okay, how did you figure that out then?
Because 15 divided by 3 is 5, and then you just add it back to 20.
So what, correct me if I'm wrong, so you're saying 15 minutes, so you want miles per minute, right? So you got 3 miles per 15 minutes. Is that right?
Uh-huh.
Okay.
And then 2 hours on a different, I don't know.
So what our slope
I'm
be?
very confused right now.
If we're going with, slope, would that be 1/5?
So Gabby weighs in here. She's doing a simplification, so she's saying 1/5. And another thing she said is she made a postulation here. She said, what if we call this thing a slope, right? Is that going to be a slope for us? 1/5? Can we go with that? So now, Bryce has given us our y-intercept, and Gabby has given us, and others help too, of course, has found the slope. And so do we have an equation we can work with now? Yeah, so what is that equation going to be? Y equals 1/5 x, okay? And then our y-intercept is 0. So is that really all we need?
Yeah.
Okay, well good. Let's go ahead And let's test if this works, right? How are we going to be able to test our function to see if it works? Well, if we plug in, if we plug in 15, we should get 3, right? Does that work if we plug in 15? Will we get 3? Yeah. All right, so that checks out. So 15 minutes, and I guess what we're doing is we're saying time equals minutes, right? And so we went 3 miles in 15 minutes. And what is at how many minutes are we going here?
Or 120.
120?
Yeah.
Okay, are we cool to put a domain here? Yeah, so what is our domain going to be?
0 to 1.
Oh, my pen is going a little bit glitchy on me. Okay, I'm thinking 0 to 120, right? So that's our domain. What is our range going to be?
Zero 3.
Well, we went 3 miles in 15 minutes, but we need to go 120 minutes, right?
24.
Oh, okay.
So so Ben suggests 24, right? Okay, so now we're going here like, this is going to be like 120, comma 24. So now the thing would look something like this, right? Something like that. Okay? Now, one thing I want to do now is I want to do an exercise in your calculator. I want to emulate this graph here in your calculator. So you get out your calculator. And we're going to emulate this whole graph and actually this function here. And what I want you to do is go to your calculator and go to Window, and our domain, I want you to put right in here. Our domain is going to be 0 to 120, is that right? And what do you want to go up by? I want to go up by 15. That's what I want to go by. Why 15?
Because that's the minutes.
That was the original thing given, right? And then for y minimum, our range, that's right, 0 to 24. And then we can just go a mile at a time, right? 1 mile. And when we graph that, we get this looking thing here. I got an equation in here. I'm going to get rid of this equation. So that's what our graph looks like, right? I mean, so it's perfectly emulated, right? We're going 0 to 120, and we're going 0 to 24. So what equation goes in here? 1/5 x. So I'm going to go put in 1/5 x. And I cheated, right? I put down 0.2. That's a good cheat, isn't it? And then we graph, we get this. Does that look like a pretty good emulation there? Yeah, it does. And we can also go where? We can go to our table view. And what do we see in our table view? Well, we're interested in minutes, right? Let's go to minutes. we want minutes, so let's go to, those are minutes, right? So we can go to our table view, and we can see that if we go 15 minutes, how many miles did we get?
3.
3, okay? And we could continue. So this is a pretty good one, because you can see minute by minute how far she went, right? I want to tell you that that I really didn't come into this class with a preconceived notion. I just kind of went where the class took me. But second period actually ended up with the equation was y equals 12x. That's what they got. What does that mean?
12 hours.
Lower.
This one here is in miles per hour, see? You went, this one here is miles per minute. And that's where we went, but you could also do this in miles per hour. In miles per hour, how would that change the domain?
Make it smaller.
Yeah, it'd be smaller, right? In fact, the domain would change 0 to 2. Okay. So anyway, this is good, a good thing. A lot of you have really contributed here today to this. Bryce, Gabby, Jaden, Ben are the ones I heard most. But everybody good on this? Okay, let's go ahead. All right, let's go to this next one here. The graph shows units sold as a function of time. Using set notation, identify increasing and decreasing intervals. What is significant here in this graph? What do you notice? What grabbed your attention?
The line.
Okay, so Jaden didn't. One second. Okay, Jaden. Okay, Jaden said something like this. He said, the line, right? Does that look like a line exactly?
The swirly line.
The curve, right?
Yeah, curve.
So the curve function. Okay, so, but basically, that was his idea and his addition. Thank you, Jay. What else? So what do we notice about it? What are the critical things here?
It goes through intervals.
Pardon me?
It goes through intervals.
Goes through intervals, okay? So Ben suggests intervals. And so how would you analyze intervals and figure out things here? What are the key points, if I may say so, here?
Maybe like your domain, right? Your highs and your low points, and then it goes from there.
Okay, so Bryce is talking about high points and low points, right? So let's go ahead and bring them into the conversation. So this here would be a high point. We got a starting point, a high point, and a low point. And what do we have here? We have continuation here, right? And so would these be our values that we're looking at here, the key things? Yes, okay. And we would call these things, what do we call these things here, especially this one here and this one here? We called it in this class, what do we call them?
Does it start with a V?
Yeah, so what these are, we called them, they go by different names, but I think the first thing we called those things was turning points, right? Does anybody remember that? Ben does, he's the one who told it to us, but those are turning points. And what are synonyms for turning points? What else do we call them? Now, okay, Peyton said vertex. Now, the thing, if we're talking about a quadratic function, that would be a vertex, right? But we're talking about something a little different here. So, yeah, so anyway, turning points would be these maximum minimums would be types of turning points, okay? And these x values, what else do we call them? Pardon me? Okay, now roots has to do with zeros, so that's related. But what we do is we call these things critical numbers. And I don't know if I've brought that up before. Critical numbers. Okay, what those are going to be x values of the turning point, right? X values of turning points. I'm going to abbreviate turning points, right? So now how do we use these? What are these critical numbers? Riley, Marcus, what are critical numbers here? Okay, how about 3, right? Because 3 would be a critical number.
So 0, 3, and 7.
So 0, 3.
Almost too easy. I wanted to say that, but I was like, that's too easy.
Sure.
I expect it to be like a big number, decimal, something over pi.
But this is really a good thing, because what happens is a lot of times people will focus on the y values, but when you're talking about intervals, you're always talking about what values? X values. Look over there. See what it says over there right behind Peyton? You see that little crossword thing? It says where, what? Domain, range. See that? That's what we're talking about here. So intervals. So how do we say, and we're saying set notation. So we call this thing f of x. So we'll say f of x is increasing on, and when you say on means on to, who said that? On the interval of. Ben, I would give you my board right now. This pen is getting pretty glitchy, so you might have trouble writing on it. On interval of. Okay, so where is this function increasing? So 0, 3, and so x anywhere else? Okay, 7, infinity. All right. And you could also just write this as x is greater than 7 too. Okay, you could do it that way. Do you see that? You could write this instead, x is greater than 7. That would also qualify. Okay, so that's where we're increasing. So f of x is decreasing on what interval or intervals? 3 to 7. So there we have it, right? Make sense? Okay, well, so we have, these would be our answers here. And again, your test next week is going to be a problem like that, right? Are you going to be good with that? Oh, Jaden just opening his eyes.
Okay. On the, where it says 0 is less than x, is it not less than or 3 or equal to?
Okay, so now, so Gabby's getting to the fine point, okay? You could actually do that, if you go like this, you could do that, and that would still qualify. And so it's sort of a matter of debate or preference, whether that's the case. I like to say, because you could say that that's greater than or equal to 0 because this is the lowest and everything to the right, and so you could say that x is actually increasing after everything including that. So you could argue that way. And I just find out that and I'm sort of looking ahead to calculus class about how things are scored. And generally, you're more likely not to get points deducted if you just leave it in the open interval standpoint. And that's a fine point. Okay, that's what really good students do. They ask those kind of nitpicking questions, but that's a very good question. Okay, so that's the best I can tell you right now. All right. Any other questions on that? That was a good one. Any other ones? Okay, let's go here. Now we have this table here, show some values of a polynomial function. So you have this table, and we're asked what is the average rate of change over each of the following intervals. And what do you think of this one?
Put it in your calculator.
Okay, is it asking you to do that?
Oh, no.
Not really. Now you could, right? It would tell you something. You put it in the calculator and do something with it. But is that what is being asked? No, it's not.
Oh, I'm done. I'm just gonna be quiet.
So what are we going to do? What does that, any of this mean? What, they talk about average rate of change. What is an average rate of change?
The slope is going to 2 points.
Yeah, so I'm going to say this. I'm going to say average rate of change equals a slope. And it'll be a slope between 2 points. And so you can get you remember your basic slope formula? Now, Bryce says y equals mx plus b. Now that's point slope form, okay? We want the equation just for slope. What is the equation for slope? So slope equals, let's go ahead, we'll just put it, let Bryce take us there. So rise over run. And how do we articulate this in terms of putting numbers in?
x2 minus x1, or is it y?
Y2 minus Y1, H2 minus
Which is rise over run, right? Another thing you can see on this is sometimes you'll see this delta y over delta x, this little triangle. You can see that. Or one way yet, you can say your slope, or in this case, average rate of change equals f of b minus f of a over b minus a. Okay, I'm going to give you a verbal description of slope. Okay, that I think is quite helpful. Slope is the answer to the question, how much does y change when x is increased by 1 unit? Okay, did you get that? How much does y change when x is increased by 1 unit? That is slope. Okay. And so we can use that actually in this particular situation. But let's use the formula first. Let's go ahead and look at this one first, at number 1, and just use the formula. So for this one here, from 0 to 1, and so we're going to say this is x2, y2, and this one here is x1, y1. Does that make sense? Yeah. And so, using that formula, what are we going to get? We get y2 minus y1 over x2 this. X2 minus
Teachers and
x1.
students, pardon the interruption. I hope everybody's had a great Friday as we're kind of coming to the end of the week.
What's this gonna be?
Hope everybody has a great weekend. It's supposed to be a beautiful weekend. If you plan to attend the volleyball game tonight or the football game, make sure you're loud and proud and cheer our teams on, and it should be a great evening. Make sure you have a ticket for either one of those
Does
events.
everybody get this?
Or you can't get in. So keep that in mind. I did pick the names for the Kickin' for Chicken event tonight at halftime. And I chose 3 instead of 2, so we're going to get 3 contestants. We had a good sign up. If I didn't pick your name this time, you can you can sign up again next week or the next home game, and maybe we'll pick it then. All right, the 3 that have been chosen. The first one is Travis Abernathy. Congratulations. Make sure you, at the beginning of halftime, come find me. Cheyenne Vick, she's into everything. I guess I hope she can kick too, so she'll be part of that. And the last one is Caitlin Batista. So congratulations on those 3. Again, if you signed up and didn't get on at this time, maybe next home game. All right, if you're there, please cheer these on as they're trying to win some chicken, and they'll be kicking. So it should be a great event. So good luck to everybody, band, cheerleaders, drill team tonight, volleyball, everybody. Make it a great night at Scurry Rosser High School, and go Wildcats.
Okay. Now from x equals 1 to x equals 2, we should be able to figure out what that is. What is this one going to be here? 10, right? Everybody get that? Because y increased by, x increased by 1. How much did y change? By 10. Okay, for this one, from x equals 1 to x equals 3, what did you get for that one? Okay, I'm going to get, on this one, I'll tell you what I got for this one. I got -5. That's what I got. Hattie, can you see that, Hattie? Hattie, was that you being tossed up into the air this morning? Man, I know I would just fall and I would be in the hospital already. Okay. And then x, so then lastly, from x equals 3 to x equals 4, you're going to have what? 80, right? And for this third one here, what you'd have is, you'd have 10 minus 20 over 3 minus 1. So you're going to get -10 over 2, right? Which equals -5. So that's where this thing comes from. Right, any questions on those? let's go on here. A polynomial function whose domain is all real numbers is positive over these intervals from negative infinity to 2 and 4 to 9. Over what intervals are the function values negative? What does a polynomial function look like? Okay, a polynomial function is either going to be a line or smooth curves. Okay, that's all polynomial functions are. So how do we find out? We'll say a polynomial function, and let's define that function as, we'll call that function f of x. Polynomial function f of x, whose domain is all real numbers, is positive over these intervals. Over what intervals are the function values negative? So we'll say f of x is going to be less than 0 on what intervals? Okay, let me go ahead and sketch something first, okay? I'm not getting a lot of takers here. Okay, what are the critical numbers here? 2 would be a critical number. What else? 2, 4, and 9, right? And so, where is the function, over what intervals are positive, right? So what does that mean? Okay, we have, our values are positive right in here, right? And where else? 4 to 9. So where are the values negative?
That's
From 0 to, from negative, I don't know.
0 to negative infinity.
Well, 0 to negative infinity, we know they're positive, because that 0 to negative infinity is included in this interval where things are positive. Things are positive here, things are positive. Where is the function negative? 2 to 4, right? So 2 to 4, and it's by what? It's like process of elimination, right? Where else? Anywhere else things are negative?
Not past 9.
Not past 9.
Why? Why are they negative right there if they're positive numbers?
Okay, well, you're not, yeah, let's continue here. So by process of elimination, we know that we're positive here, and so just by process of elimination, the thing is going to be negative everywhere else. So everywhere else the thing is not positive, it's going to be negative. Now, it could be at 0, but we're not talking about zeros either, right? So what is the graph of this thing going to look like? This is just a number line, right? And so here we have our negative values here. I'm going to put in green. Okay, and then right here, going towards positive infinity. So let's go ahead and back off and look at a coordinate plane here. So we put this in an XY coordinate plane, and we mark our critical numbers at 2, 4, and 9. So we know we're positive all the way down. Remember, polynomials are smooth, right? So we know that the thing is going to come from negative infinity. It's going to come right here, and it's going to go like this. And then after 2, the thing is going to do what?
Go back up. Or go down.
It's going to be negative. So what happens? You have positive in this interval here, and you also have positive here too, right?
Oh, okay.
And so to fill in the rest of this polynomial curve, what do we have to have? We have to have this kind of business here somehow, right? And also this business here. So here, okay, we'd have f of x is less than 0 in these two intervals here. So we would say our answers would be on 2, 4, U, 9, infinity. Does that make sense?
Yeah, it makes a lot more sense now.
Yeah.
I didn't know you were going on the graph point of view. I thought that was like a number line.
Well, they are. They're two different things, okay? This right here, this number line, is like a one-dimensional view, right?
Yeah, I get that now. Okay. that
Because what happens is, if we collapse this graph down onto the x-axis, it would look just like this, right?
Yeah.
And if I color code properly, what's above the x-axis should be red, right? To color code with the number line, right? This interval would be consistent here, and this interval would be consistent here, and then the green ones would be represented here. So this is like a 2D representation. And we're going to do that more this year, and those of you in pre-calculus, we get more into that next year too. Okay, the last thing we're going to do today, was this helpful going over this today? Yeah. This thing right here, other classes asked what that U is. That's representative of union. And this is interval notation, which was given. Okay, last thing today is this. Find the equation of the line of best fit for the data in the table. And then I want you to use your calculator for that, okay? Does everybody know how to get that? To go to stat? Marcus, you know how to do that? Stat edit? And put these values in? Addie, you know how to do this? Does everybody remember how to get the equation? You remember, Jaden? Now this is what you were talking about doing earlier when you saw that table, right? And which is not a bad instinctive reaction. Then you just read it carefully. Oh yeah, this is what there is. Okay,
Those are the numbers that we are on the one we're on right now?
Yeah, this would be the numbers from the table. If you look at the table, 1, 2, 4, 6, 7, 2, 7, 10, 15, 17, see that? That's what they are. Okay? So they're just transcribed. And this is working from a 7th period class. How do you find the equation of a line?
Linear, grid.
Stat Calc 4. Stat Calc 4. Stat edit Stat Calc 4. Oh, is that it? That's a quadratic regression. I got to do different, right? Stat Calc 4. I put 5. This looks better, doesn't it? So what is our equation going to be? So if you go to 2 decimal places, it would be like 2.35x, right? Plus 0.82. So y equals 2.35x plus 0.82. And then you can test it out in the calculator, right? So you can go here, and you can put 2.35x plus 0.82, and if it matches, what should we get? I'm going to go to table set. I'm going to go, yeah, table set 1. So we could go and find it out, right? Does that work out? Okay, 1 was 3, right? That's close. Let's do this. I want to go here and plot. And then we'll set the window. We'll go 0 to 10. And y, we're in x scale 1. And then we go y minimum 0 to 20, right? Will that get it? 20 by 1. We should see everything. We should see is that what you got? So that's your line of best fit. You can see how close we are. Okay,
How did I get that?
you didn't get that?
My line's going more up towards the y-axis.
Well, it depends on how you have it scaled with your calculator, but it can help you with that.